Hello, and welcome to the Maths Behind Economics YouTube channel. This is the first series on this channel, and the first series will focus on exponents for economics. This is the first video when we're going to talk about the exponent rules. I'm going to introduce the definition of an exponent, then we'll focus on the vocabulary, and then we'll dive into the exponent rules. I'm going to cover them in two different groups. First, we're going to talk about the rules which involve the same bases, and then we're going to talk about the rules which involve the same exponents. So let's get started. First of all, let's cover what the definition of the exponents are. So if you've got any number and you want to raise them to some kind of power or exponent, by definition, so pay attention to the fact that I've used a colon and the equation sign, not just the simple equation sign. In mathematics, this always means that we are now defining, we are now explaining, we are now giving you the exact circumstances in which we will use this kind of notation. So what does this actually mean? Well, it means that we will pick up the same number and we keep repeating, multiplying this number by itself until we reach the desired number of times, which in this case, in generic, n. So what does it mean in practice? So for example, if you've got something like 3 squared or 3 raised to the second power, that basically means I pick 3 and multiply it by itself twice. Another example, if I've got 5 cubed or 5 raised to the third power, which it means is I'm multiplying 5 by itself 3 times. One last example, I pick up 7 and I raise that to the fifth power, 7 to the fifth. That is multiplying 7 by itself 5 times. I need one more. 1, 2, 3, 4, 5. I hope that you agree with me that this notation, which is kind of a shorthand notation, much shorter. So writing out 7 multiplied by itself 5 times takes quite a bit of time and space. So mathematicians are lazy, they like to use short things. Right, so that was the definition. Next, we're going to focus on the vocabulary. Right, let me just make a bit more space. So in the vocabulary, when you look at this notation, there are 2 numbers involved. I'm going to use separate colors for the 2 numbers. The big number and then the small number up in the right hand corner. Now, what's the difference between the 2 of them? We kind of have to use different names for them because obviously they have got different rules. So the big number we call the base. This will always tell us which number to multiply by itself. And the other number, the small number the small number up in the right hand corner is called the exponent. Sometimes it's also called the power, and I'm going to use both the exponent and the power interchangeably. And it's also sometimes called the index. Well, not so much in economics, because in economics an index number means something very specific. So most of the time I'm just going to refer to it by either exponent or power. Now, what does the exponent or the power do? Well, it tells us how many times to multiply the base by itself. So the 2 numbers have got very different rules, and there is a real difference between them. So remember, if we write something differently in mathematics, it will mean something different. Mathematics is a very notation heavy subject, so you really have to understand the difference between the notations. So for example, if I have got 3 squared, that's definitely not the same as 3 times 2. Okay, so the 3 squared, as we seen just a couple of minutes ago, is 3 by 3, while 3 times 2 is also a shorthand notation, but 3 times 2 is the shorthand notation for adding 3 by itself twice, okay? So it's also a shorthand notation. While with the 3 times 2, it doesn't really make much of a difference, but if you look at 3 times 5, now that would mean 3 plus 3 plus 3 plus 3 plus 3. So you're adding the 3 together 5 times. So again, you can see the power of this shorthand notation. So again, be careful. If we write something differently in mathematics, it will mean something different. So we covered quite a bit of ground so far. Let's move on to the next. The big topic for this video is the rules of exponents. I'm going to group them into 2 different sections. One will be when we're talking about the same bases, and the other one, and I'm going to use different colors for them, when we're going to use the same exponent. Okay, right, let's bring that a little bit further down, and then let's dive into and look at all these different rules. So let's start with the rules when the bases are same. So if I have got the same base numbers and I multiply them together, but the powers are different, that's the same effect when I'm adding the powers together. Now I'm going to have a separate video on each of these rules. For now, I'm just listing them so we have them all in one place. When I have got the same bases with different powers or exponents, but I'm dividing them, that's basically the same effect as I keep the same base and subtracting the powers. There are some special powers. So if I raise something to the 0 power, that's going to be equal to 1. If I raise something to the first power, that's going to be equal to itself. And if I raise something to the negative power, that's going to be the same as 1 over the positive equivalent of that very same power. There are a couple of more in the groups of the same base powers. One is when I'm raising a power to a power again, and that is the same effect as if I'm multiplying those powers together. And there's a nice connection between the roots and the powers, and we can capture that in the form of fractions. Okay, so if I have an nth root of something raised to the mth power, that's the same as the number, same base number, raised to the m over nth power. Okay, so these were the rules when we have got the same bases. Now, what happens when we have the same exponents, right? We're going to have a few rules in here. So what happens if I have got 2 different numbers, but I happen to have to raise them to the same power? Well, that is the same as if I'm raising them separately to the same power. Now, in algebra, remember, if there's nothing in between the numbers, in this case letters, then it's always multiplication. Now, what happens if I have a fraction with a different numerator and the denominator, and I raise that fraction to the same power? Well, I can raise the numerator and the denominator separately. So the numerator is the top number, the denominator is the bottom number. And now what happens if I have got that same fraction, but now I'm raising it to a negative power? Well, in this case, the effect of the negative is that I'm switching the roles of the numerator and the denominator. So whatever was the numerator in the original one, because of that negative, it's now going to be the denominator. And whatever was the denominator, because of that negative, is now going to be the numerator. But because they raise to the same power, I'm going to raise them to the nth power separately, right? So these are all the different rules. Let's see them all in one shot. So these are the rules when we have got the same bases. When you multiply the same bases, you add the powers. When you divide the same bases, you subtract the powers. There are some specific powers, like the 0 power is always 1, the first power is always the number itself, the negative power is the 1 over. When you're raising a power to a power, you multiply them together, and there is a nice connection between the roots and the powers, which we express in a fractional form. Now, on the other hand, when we have different bases raised to the same power. For example, if you multiply them, you can just multiply those different bases and raise them to the same power. If there are fractions, then you just raise the numerator and the denominator separately to that very same power. And if you're raising a fraction to a negative power, you just have to switch the role of the numerator and the denominator, and you're still raising them to the same power. I hope that helps you to remember all these different rules, and I'm looking forward to seeing the next video when we will be discussing these in more details.